So this is going to be one of the two types of problems. We're going to do two examples of it. Like I said, they're slightly different. And then the third example is a very different one. But you've seen all of these in grade 10. These are the same as the ones that we did in grade 10. So you should have seen them before. People, word problems like these, application questions, are famous for being hated by students. It's another one of those funny things where people complain, when am I ever going to use this? Right? Like, why am I learning this math? I'm never going to use it. And then we do word problems, which is where you would actually use math in the real world. And then people say, oh, I hate word problems. Well, make up your mind. Do you want to do real life questions or not? Now, this isn't really a real life question necessarily that you would just see walking down the street, but they are examples of the kinds of problems you might see in trying to solve, whether it's in business and just working with numbers, or we'll see in the third example something that is a little bit more real. The point is, even word problems or applications can be broken down into steps. Even applications I can break down into step by step if I'm struggling with them, okay? We're only doing two types, so you only have to know how to solve each type. And when you do the practice, the worksheet is going to have multiples of each type. So that's an opportunity for you to run through it and figure it out using the lesson as your model. You set up every question exactly the way we're going to set up these ones, okay? But try to pay attention to the little hints that I'm going to drop along the way and the important things that I'm going to tell you to look out for, in particular if you tend to struggle with word problems, okay? So here we go. First step, what's interesting is, I think a lot of people don't like this part of in high school when we start making you do this. What do we often, does anybody remember what we often start these kind of word problems with? Let statements, very good. And people don't like it because it's writing, but it's actually a useful part of the solution. Not only is it good for your reader, because then they know what you're talking about when you say X or when you say A or M or whatever variable you choose, but it's actually going to be useful for you near the end of the question in a lot of situations that you've defined your variables, okay? So two numbers have a sum of 18. And here's the trick to let statements. 99% of the time, you're letting X represent the thing you're trying to find. That's almost always the case. Okay, so if you're ever not sure what to let your X represent, it's almost always the thing you're trying to find. There's one case where that's not true. In high school, there's a couple of cases, but for us, there's only one case, and we're going to talk about it today. And then once I point that out, you'll know, oh, this is the kind where I have to let X represent something else. Okay, so let's go ahead and get started. Let X, so we're trying to find two numbers. What are the numbers? Let X represent one number. And since there's two numbers, I'm going to use a second variable. Let Y represent the other. I don't want to confuse anybody. There are slightly different ways that you can do these questions, and I think some teachers do them a little bit differently from each other and from me or whatever. Some might not use two variables. Some might only use one. And if you want to do it that way because you've seen it that way in the past, or that's what makes sense to you, go for it. I'm going to show you how to do it with two variables because I think it can be a bit more of a step-by-step way of doing it. But if you're successful doing it the other way, that's fine. It's basically the same thing. Okay? And I'll talk a bit more about that after. But this is how I like to do it. So step one is define your variables. What are you trying to find? I'm trying to find two numbers, so I let my two variables represent those two numbers. Step two is we're going to write a tiny little equation. Okay? It says here two numbers have a sum of 18. If my two numbers are X and Y, how can I write that in a math sentence? What does it mean for my two numbers to have a sum of 18? You're adding. So if I add the numbers together, they'll be 18. So doesn't that mean x plus y equals 18. Right. Step 1 is your let statement. Step 2 is to come up with this equation and solve it for one of the variables. If you want to use x in your equation, you want to solve this for y. So how do I solve it for y? I move x to the other side. And y is equal to 18 minus x. Is everybody okay with that? Easy so far, right? And we're not doing other kinds of word problems that you have to figure out yourself. Every kind that I'm going to ask you to do is going to be one of these types that we're practicing together, pretty much every kind. So, like, you just need to kind of get used to these steps. Step 1, let statement. Step 2, do this little equation and solve it for one of the variables. Step 3, what am I actually being asked about? I'm being asked about a maximum product. Maximum product. So what I have to do is come up with an equation that has to do with a product. What does product mean? Multiplication. So my next step is to come up with that equation. I'm going to use capital P for product. You can use whatever variable you want. The product of those two numbers is x times y, xy. Is that okay? There are other kinds of questions that you probably did in grade 10, like the sum or the square of the sum of two numbers is a maximum or a minimum. Like, there are slightly other versions of this, and that's where that would change this step. Instead of a product, you'd be talking about the sum of the squares or the square of the sum or something slightly different like that. Okay? Otherwise, it's the same general idea, but we're just doing product. So the product of those two numbers. Now the last step before I can go ahead and start doing some solving is I can't solve this if I have two variables. So I have to sub in for y. Y is equal to 18 minus x. So I sub that in. Now I have an equation in one variable, and I'm actually going to use function notation just because that was something we learned. And I'm going to say p at x. Now, I couldn't say that in the line above because it had an x and a y. But once I only have one variable, I call it p at x. The only reason why you don't have to do that, you could just call it p. Okay, you don't have to use function notation here. You might like to because it's kind of fancy. You might like to because it reminds you you have to get this in terms of a single variable. Not okay to leave it as two variables. You're not going to get anywhere. Okay? And that's the setup. The rest of it is doing some math. So this is the word problem part of it. And that's probably the part that people struggle with most because they just don't know where to start. But like I said, pretty much everything I ask you to do is going to be the same format. So you do those steps, and then we get here, and you forget that this is a word problem, and you just go ahead and solve it. And then at the end, we go back to word problem, and we interpret our solution. Okay, that's how word problems or applications tend to work. You get it set up, then you just do the math and forget about the whole word problem, and then your interpretation of your answer at the end. Before we move on, if you wanted to avoid using two variables, you have to be able to come up with this without that. So when it says the two numbers have a sum of 18, you could say let x represent one of the numbers, then 18 minus x is the other number. If you can just come up with that, you don't need to introduce a y. But some people struggle with that. They struggle with that relationship. If I add two numbers and it get 18, then it's 18 minus the number. Right? That's the relationship. And that might seem backwards. The next example is probably going to be more obvious. But when you're adding them, people can't always do it. So to avoid that, you introduce a second variable, and you just come up with the easy version, which is x plus y. And then you solve it. And you can solve it for x or y. It doesn't matter. Is everybody okay with this so far? Okay, now I've got this equation. I've got it in one variable. It's the product. We are maximizing. You don't have to write this down when you're doing yours, but you should be thinking about this. Maximizing product. That's why I have an equation for the product, because that's what's being maximized. This is a quadratic. When I expand it, I'm going to get an x squared. How do you find the maximum or minimum of a parabola, of a quadratic? Where does it happen? This is what we just did. Yeah? But what's the name of that point called where the maximum happens? It's the vertex. So to answer this question, to find the maximum, we need to find the vertex. How do you find the vertex? Put it in vertex form by completing the square. Okay? In this unit, that's what we're always going to do. In the next unit, it changes a bit. But this unit, all the questions are about maximizing. So you're always going to complete the square. You don't even have to really know that. You just, you don't have to figure that out. You should just, every question is going to work out that way. Okay? But the fact that I'm maximizing product means I need an equation for product. And to find the maximum of a quadratic, we have to put it in vertex form. So remember, the first step is to make sure that it's in the proper form to complete the square. This one is not. So to put it in the right form, I have to expand and simplify, right? So x times 18 is 18x. X times x is negative x squared. Are we following what I'm doing and why I'm doing it and everything? Everybody's okay with this? I'm just going to rewrite this in the proper order because trying to complete the square when it's not written in the right order is going to be really hard. And now, of course, this has a plus 0. You don't need to write it, but it's there. You understand now. Back in grade 9, a lot of students probably don't get, who cares what order I write these things in? Why do I have to write the squared term first? Who cares? Why are you so picky? Now we understand. Completing the square would be hard if they weren't written in the same order because we're just not used to it. Factoring is hard if it's not written properly because we're not used to it. So I want to write it in the right order to make it easier on myself. Now you understand. It's so interesting. Now you can look back and say, oh yeah, I get it now. It makes perfect sense. I think that's interesting. Okay, so we're going to factor out the negative. That takes 18 from being positive to becoming negative. How do I complete the square? Got to find that number. Half of 18 is 9. 9 squared is 81. Add 81. Subtract 81. It has to be inside the brackets because I've got a number out front. Pull the negative version out. Multiply by, in this case, just the negative. So it becomes plus 81. And then finish it up with my last step. Notice during all of that, we didn't talk once about how this was a word problem. I could have given you that question before we ever started applications, and I mean, we didn't do a lot of expanding first, but if I had given you this question, you would have gone ahead and completed the square, right? So that part of it has nothing to do with the fact that it's an application. But it's that setup that is the trickier part. Okay, now I'm going to summarize this, and I think this is a good habit to be in, especially if you like that structure of steps in order to solve a word problem. Whenever you're finished completing the square, write out the vertex and say whether it has a max, a min, or a min, and where it occurs. So this is opening down, so it has a max. The max is 81, and it occurs when x equals 9. Positive 9, because x minus 9 squared means it's shifting to the right 9. You don't have to do that part, but it's a strong recommendation. It's a good thing to do to help you interpret your answer and remind yourself of what you're doing. Now, these ones are a little bit strange to interpret, at least at first. They're always the same, so once you get used to it, it's fine. But a lot of word problems, like in the next unit when we do a word problem, the answer will say x equals 5, and 5 is your answer. And that's how we like it. This doesn't say x equals something, does it? So where is our answer in all of this? We'll get used to it when we practice, but I'm going to go back up to my let statements. And what the question was, their product is a maximum. Okay, well, I got a maximum. That's good. What are the numbers? X and Y are the numbers. Well, I do have this x equals 9 thing written here. And what is this a max of? It's a max product. So 81 is the maximum product, and it happens when x is 9. X is one of our numbers, so the product happens when one of our numbers is 9. Does that make sense? Okay, so I can think about what the 81 is and what the x is. 81 is the product, because it's always this thing, whatever that represented, and then x is when it happens, which is in this case is when one of the numbers. Okay, so I'm going to say one number, x equals 9. Other number. What's the other number? The other number is y. Y equals 18 minus x. But I know what x is. It said find the two numbers. What are the two numbers? Two numbers are x and y. We've already got x. We've got to find y. Y is 18 minus x, but I know what x is. So that's 18 minus 9, which is 9. What's interesting about that? My two numbers are 9 and 9. What's 9 times 9? It's 81. That was the maximum product that we saw. Therefore, the two numbers are 9 and 9. It's not okay to just find them. You have to show this. Like, you could probably have figured that out. And you're going to see a pattern in a lot of these questions, and you could just guess at the answer. But you have to show the full solution, right? Full solution requires let statements, requires setting up an equation, completing the square to put it in vertex form, and then interpreting that. Any questions on that? We're not quite done. Oh, yeah, we are done. What are the numbers if their product is the maximum? Sometimes it says what is the maximum product, but this one doesn't. So we're done. Questions, questions, questions. So before we move on, people also are confused, like, well, okay, like I get it, you know, and I get the steps and like it all makes sense, but what is this even talking about? There's all kinds of pairs of numbers that add up to 18. How about 10 and 8? They add up to 18. Two numbers have a sum of 18. 10 and 18. Sorry, 10 and 8 add up to 18. What's 10 times 8? 80. Smaller than 81. What about 11 and 7? They add up to 18. 11 times 7 is 77. Smaller than 81. Of all the pairs of numbers, of which there are infinite, all the pairs of numbers that add up to 18, like 20 and negative 2, add up to 18. 20 times negative 2 is negative 40. Smaller than 81. They're all smaller than 81. 81 is the biggest. That's what it's saying, right? Okay, let's move on to the next one so we can get them all done in time. So the only thing that's different about this one is it says the two numbers have a difference of 12. This is actually the easier one in some ways. Two numbers have a difference of 12. What are the numbers if their product is a minimum? I'll go through this one a little bit more quickly because most of it's the same except for one part. Is that okay? So we start with let statements. Oh, you're writing this down still, sorry. Two numbers have a difference of 12. What are their numbers if their product is a minimum? What is the minimum product possible? So this one asks for the minimum product. Okay, so we start with let statements, and they're going to look the same. They're going to look the same as in the last case. Let x represent one number. You do not always have to use x and y. In fact, maybe you want to avoid y because y to you feels like the y-axis. And if that's true, use a and b or whatever variables you want. Okay? Let y represent the other number. What does it mean if they have a difference of 12? You're subtracting. So x minus y is 12. The difference between the two of them is 12. So that's the only thing that's different about this question. Everything else is going to be basically the same. Okay, so I do the same thing where I have to solve for one of them. Last time I solved for y, this time I'm solving for x. It's going to make things look a little different, but it's the same thing. It would have been a bit tricky to solve for y because it's of the negative y, but if you could move the y to the other side and then move the 12 over, or you could have started with y minus x equals 12. If you're picky about that kind of stuff, you can try to figure that out. Or you just see what happens. So this one again says product. So product is equal to x times y. Now I've got x equals, so I have to sub in for x. And instead of an equation in terms of x, I've got an equation in terms of y. And I think it's best to just be comfortable with that and not worry about it. If you are worried about it, like I said, use a and b, and then you won't care. That y is not the same y as when you graph. That y just represents one of the numbers. It's got nothing to do with graphing, like a y-intercept or something like that, okay? Same thing, now we just expand and solve. Sorry, not really solve, but we expand, simplify. To solve, we're completing the square in order to put it in vertex form and find that minimum value. So I'll do this quickly. Half of 12 is 36. I didn't have to factor anything out this time, so I skipped that step, right? if you don't like that, we would have brackets around that part. In this case, we were minimizing product. So my vertex is -6, -36. I shifted left and down. It's opening up because it's got a positive out in front, so it's got a minimum of -36 when y equals -6. It's important that we know that's y. Otherwise, that's going to cause a problem. So don't call it x. If it was y up above, then it's y here. We okay with that? Now we have to interpret. So the first number is y equals -6. Second number comes from that x equals 12 plus y. This is why let statements are important, because at the end of it, you're like, what am I supposed to find? I'm supposed to find the two numbers. The two numbers are x and y. So I have to find x and y. Y equals -6. What does x equal? I've got an equation for that. I've got an equation that says x equals. And I can solve it because I know what y is. So now I know how to solve this problem. Are we okay? I'm not going too fast. Therefore, the two numbers are 6 and -6, and their product is -36. So it said to state the minimum product. Well, we've got that written down here. I can also just do that in my head. -6 times 6 is -36. So whether you recognize that it was in our equation, we already know the minimum value, or whether you just figure it out at the time is up to you. We got one more. Everybody okay with this? All right, like I said, this one's a little bit longer. You can wait and write it down after if you don't feel like writing it down right now. Either from the classroom or I'll put it back up. If you're going to write it down, and I'll give you a couple minutes to do that, or a minute at least, but if I start doing the question, you probably want to stop and just leave space and go back and fill it in after. So we did two examples of minimizing product. And that's all it said was, what are the numbers if the product is a minimum? What are the numbers if the product is a maximum? Right? That's all it said. Two examples. One was a sum, one was a difference, very similar. This one's obviously totally different. This is what we call a revenue question. So it's the other type that we're looking at. I would expect on the test there will be one of each. So there'll be a product question and there'll be a revenue question. So you got to know how to do this. The thing about the revenue question is they're a little bit different. They're a little bit strange at first, but once you get it, they're all the same. It is a formula. It is just a set of steps.
Is there any way to
Not really. I'll look at the thermostat and hopefully they will turn on the heat soon. But the thermostats in these rooms don't do any. They almost do nothing on a good day, and if the furnace is even, if the heater's not even on in the building, then turning the thermostat won't do anything. Won't turn it on. I'm sure the heaters aren't on. It is very cold. I agree. Okay, so this is a revenue question because it says what is it talks about maximizing revenue. Coffee shop sells coffee for $2 per cup. And last month they sold 6,000 cups. Store manager is planning to increase the price. And think about this, this makes sense. If you increase the price of coffee, fewer people will buy it, right? And if you keep increasing it, eventually nobody would buy it. If you decrease the cup of coffee, if you make it cheaper, probably more people will buy it. You'll sell more cups, but each makes less money because you're selling them cheaper. So there's some balance between the price that you make something and how many you sell that will maximize your revenue. Okay, so he's going to increase the price, and a consumer survey, some magical survey somehow showed that every time they increase the price by 5 cents, they will sell 100 fewer cups of coffee per month. So I guess they surveyed their customers or they surveyed random people. What should the selling price be to maximize revenue? And then what is the maximum monthly revenue? Okay, I'm going to get started. This is the kind of question. It says, what is the selling price? You do not let X represent the price. This is the one type that we're going to see where the thing you're being asked to find is not what we let X represent. Everybody get that? So you have to know what you let X represent, and we have to understand these little things that we come up with, but then we just do the same thing as we were doing the last time, complete the square and interpret the answer. And they're the same every single time. So even if you don't fully understand the first time through, when you're practicing, try to just follow the lesson with what we did, and then it should become more and more clear. So if we're not going to let X represent the price, what are we going to let X represent? And you did these in grade 10. You should have done them in grade 10. So maybe you would remember what it was, but a lot of people probably don't. And this is not something that I think most people would ever figure out. This is one of those ones where somebody kind of has to show it to you. There are some applications that you can figure out on your own. But this one would be really tricky because it's just not obvious what you let X represent. Okay, so in this case, we're increasing the price. So we are letting X represent the number of increases in price. You can't just say let X represent the increases. You can't just say let X represent the price. You have to say the number of increases. Really important. So if there's anything you learn about these revenue questions, that has to be it. Because if you don't start with the right let statement, nothing is going to work. Okay? What is revenue? Revenue is not profit. Profit is how much money you bring in minus how much you have to spend. Whatever's left over is how much you get to keep. That's what profit is. Revenue is different. Revenue is just what you bring in. Revenue equals the price times number of sales. So the original revenue was $2 times 6,000, which was $12,000. That's the revenue. Now, every cup of coffee costs money to make, so they don't get to keep all of that. But that was the revenue, $12,000 on coffee. We have to figure out what the new price is and what the new number of sales will be And then we can make an equation that we can use to finish the question. So, old price, was $2. What is the new price? Well, the new price is increasing. So it's going to be more than $2, yes? With one increase, it would be $2.05. With two increases, it would be $2.10. With three increases, it'd be $2.15, and so on. But I don't know which one of those things it is. If it has three increases, X is 3. If it has 10 increases, X is 10. And it would be 10 5-cent increases, which would be 50 cents. $2.50. Do we get that? So the equation for this is going to be 2 plus the increase times the number of increases, and that's why we need X to be the number of increases. A couple things happen here. In some cases, you're increasing the price. In some cases, you're decreasing the price. So if you were decreasing the price, it would obviously be minus. Okay? This is the amount of the increase. X is the number of increases. I'm adding because it's increasing, and that's what it started at. But every revenue question is the same. So you're always going to have that type of a mini formula in here. And it's important. It's really useful if you understand it. Okay? If you understand why this is the way it is. Because you could memorize it, but you're going to be a lot better off if you understand it. The original number of sales was 6,000. The new number of sales so it says she will sell 100 fewer cups. The sales is going down because it's more expensive. So it starts at 6,000, but it's going down, so I need to subtract. And for every increase, which is X, it's going down by 100. So what am I subtracting? 100X. If I increase twice, that's a 10-cent increase. The price would be $2.10. And I would sell 200 fewer cups because it decreases by 100 every time. So I'd be selling 5,800. This is key. This little part is like the key to solving these. Coming up with this and this is what you have to do. That's the harder part. But every revenue question is the same. As we said, revenue is equal to price times number of sales. We want to know what we want to maximize the new revenue. So I use the new price and the new number of sales. And I'm going to call that R. Remember, the setup is the hard part of these applications. That took a lot of work. Now, a lot of that was just explaining. It'll be faster when you're doing it on your own. You don't have to write out the old price and the old number of sales, but you probably do want to write out the new price and the new number of sales separately and then put them into this equation. And that helps you focus what you have to do. One is always going to be plus, one is always going to be minus. Because if my price goes up, my sales go down. If my price goes down, my sales will go up. So one's always going up, one's always going down. Are we okay? Now it's just expand, simplify, complete the square, put it into vertex form, and get the maximum and where it occurs. Right? Now it's just all of that. Again, it's the setup that's the tricky part. Okay, so I'll go through this part fairly quickly. Now, you've done this before, but we haven't done this in the work that we've been doing the last couple of days, where you've got two binomials here that you have to expand through. But it's just this, right? 2 times that and 2 times that, and then 0.05x times that and 0.05x times that. So I'm just going to expand. So this is 12,000 minus 200x plus 300x. So 0.05 times 6,000 is 300. Minus 5x squared. I'm going to write it in the correct order. I'm going to add those two together. Okay, now it's in the right form and we can complete the square. Factor out the -5. Don't forget to divide the 100 by -5 as well. Half of 20 is 10. 10 squared is 100. $100 times -100 times -5 is positive 500. And then I write out the final step. We were maximizing revenue, maximizing R, so the max R is 12,500. And that's when X equals 10, because I'm shifting to the right 10. That was all the math. Nothing to do with the application. Now we have to interpret it. When it says X equals 10, what does that mean? I go back up to my let statement. What is X? Oh, X is the number of increases. So I need to increase 10 times. That's what that means. Right? The let statement helps me interpret my answer. Helps me make sense of it. So, therefore, you don't have to write this part, but therefore, 10 increases. But it says, what should the selling price be? So the new price again, I've got that written down here. New price is right there, 2 plus 0.05x. So the new price should be $2.50. 10 increases of 5 cents each is 50-cent increase, $2.50. That was all for A. B says, what is the maximum monthly revenue? Well, I've already figured that out. I could go ahead and plug it into the formula and figure that out, but it's right here in the final equation when I completed the square. So why not just use that? Max revenue is 12,500. So I just write it as a sentence, and I include units or whatever explanation. In this case, units is the dollars. But you have to write that out like a therefore statement.